Hello and welcome to Math 253 Calculus 3 here at Cañada College. My name is Lapuz. In this video we will do an example from a homework problem from section 4.7. And in this problem they're asking us to look at this engineer's design of a pipeline that connects the point P to S. Engineer decided to do this in three sections. The first section runs from the point P to Q, and it costs $50 per mile to lay. And the second runs from Q to R, costing $42 per mile. And the third runs from R to S, and that costs $40. So we want to look at the diagram below. And here are the three parts. The three parts are going from P to Q, and then we want to go from Q to R, and then finally we're going to go from R to S. Okay? And we want to essentially find the measurements of these things and find the cost. So if this is 2 miles and then X is your number of miles going along the horizontal for this first part, then the cost for this first part will be, they said it was $50 per mile, and we want to essentially measure this hypotenuse of this right triangle. So given that we have two sides, 2 and X, the hypotenuse should be the square root of 2 squared plus X squared. So that will be the cost for laying this first part down. Similarly, we will find the cost for laying this second part down to be $42 per mile. And again, the hypotenuse of the triangle would be the square root of 1 mile plus y miles squared. And then finally, we want this part over here, which is just looks like it's just a horizontal line that we're computing. And this whole measurement from the beginning to end here is 10 miles. So we want to start off with 10 miles and take away a y and take away an x length. So the cost for this one will be $40 per mile. And then this is going to be a measurement of 10 minus y minus x. So now, if we put these together, the total cost would be a function of x and y. So we'll start off by saying c is a function of x and y. We'll call c for cost. And then this will be the sum of all these things. So $50 times 4 plus x squared plus $42 times the square root of 1 plus y squared plus $40 times 10 minus x minus y. So now we have a function to work with. We are interested in minimizing the cost, so we will be interested in finding the critical points and making sure that the critical points would meet our criteria to be the minimum. Now, technically, we should have a boundary for this, and it looks like the boundary for both x and y is that they just cannot be over 10. So looks like x and y just has to be, well, it should be positive, and it should be less than 10. And realistically, x plus y should be less than 10. So we can throw in that restriction as well, but I don't think we're going to need to worry too much about that. All right, now we want to find the derivative with respect to x. In order to find critical points, we find the derivative with respect to x and then set it equal to 0. So we have a constant 50, and this is going to give us a 1/2 4 plus x squared to the negative 1/2 power times the derivative of the inside, which is 2x. Now the second term will not have does not have an x in it, so the derivative with respect to x will be 0. And here is just negative 40 times x, and the derivative of negative 40 times x is just negative 40. So I believe this is all we have. Let's see, we can cancel the 2's in here, and then we're going to set this equal to 0. So when we do that, we can say that well, let's see. Let's write this as 50 and then times x over the square root of 4 plus x squared is equal to positive 40 if we bring that over to the right side. Well, there's a couple ways to solve for this. I suppose we can divide out or do something convenient. I don't know what the convenience might be. Maybe we'll divide out by 10 and then bring this denominator over, so we have 5x is equal to 4 times the square root of 4 plus x squared under a square root. And then if we square both sides, we get 25x is equal to, this is going to be squared 16, and this is 4 plus x squared. Oops, this should be squared as well. And if we try to solve for this, we'll bring, this is going to be 16x squared, so that's 25x squared minus 16x squared, so it'll be 9x squared is equal to, and then 64, I believe, and then x is equal to 64 over 9, or x squared is equal to that, so x is going to be 8/3. Now technically it's a plus or minus, but since we are looking at lengths, let's just ignore the negative part of it, and then we have ourselves our x value. Now, given that we only have one x value out of this, it probably is a good sign because this will be the only critical point, depending on what we get for c sub y. But if we do only get one critical point, then maybe that's a good thing. All right, let's find c sub y. C sub y is the derivative of the function with respect to y. And we can start off by setting this equal to 0 because there's no y's in there. And then we have a 42, and then a 1/2, 1 plus y squared to the negative 1/2 times the derivative of the inside, which is 2y. And this is 400, the derivative of that is 0. Negative 40x, derivative of that is 0. And negative 40y, and the derivative of that is just negative 40. So we seem to have something very similar to what we got for the x component. So if we set this equal to 0, I think we cancel the 2's. So we have a 40. We'll start with a 42 y divided by 1 plus y squared with a square root, and is equal to positive 40, and we'll multiply both sides again. I think we can take out a 2, a 4, nope, just a 2, so this will be 21 y is equal to, take out a 2 there, this would be 20, and then we'll multiply by 1 plus y squared to both sides. We'll square both sides, and I need to know what 21 squared is. I think 21 squared is 441, y squared plus 20 squared is 400, and this will be 1 plus y squared. All right, we keep going with this. we have 441y squared minus 400y squared, so that's just going to give us a 41y squared is equal to, and this will give us a 400. We'll solve for y squared, 400 over 41, and square root of 400, I believe, is 20. So y is equal to 20 over the square root of 41. And here's our y value. So our critical point, therefore, our critical point is going to be 8/3, comma, 20 over the square root of 41. Now, this is probably the minimum value already, and I would just guess that this would be the minimum value. Because if we use the endpoints here, we can see that if we use any of these endpoints, either x is 0 or y is 0 or x is 10, y is 10, you're just going to get zeros for the cost because things will disappear. So I don't think we need to worry about that. What I am interested in is to find the cost when we lay down 8/3 mile for the first part and 20 over root 41 miles for the second part, and see how much that's going to cost. So we would essentially put it back into this formula, and so we're putting 8/3 in for x and 20 over root 41 in for y. And what I'm going to do is I'm just going to do this off to the side and have a computer do it for me. 20. Okay, and it looks like it's going to cost $472. $472.80, let's call it 81. It's 80.6. So that's the cost. So essentially you have your x and your y value. In this particular problem, it's just looking for the x and y value. So these are the values that you would input. But if you wanted to know the cost, it would be this cost. Okay, and yes, I do believe that this is a minimum value. Anything else you put in there would maximize it or make it larger than that. I think I said 0, but I don't think it would be 0 because it would make things really large. And in fact, this is the minimum. Another thing you could do is you can use Calcplot3D or some other graphing program to graph this, and you can see when the x values 8/3 and 20 over root 40, you should get the lowest point on this graph. Okay, that's it. I hope that helps. Good luck.